Here's pre-calc. It's part 2 of 5.1.1. We're trying to just get through this first problem. It's all word problems. So I already did letter A in a different video. Letter B says atmospheric pressure is the pressure exerted by the weight of the air in the atmosphere of Earth. It's caused by the weight of air above the measurement point. As elevation increases, there is less overlying atmospheric mass, so that atmospheric pressure decreases with increasing elevation. At sea level, which is 0 feet, the atmospheric pressure, I want to write that down. The atmospheric pressure is 101. For every 500 feet of gain, the atmospheric pressure decreases by 1.8%. What is the atmospheric pressure at an elevation of X feet? All right, so I think I found our starting point, because we're trying to put these into y equals a times b to the x form. So I'm thinking 101's got to be our starting point. So at least that part was easy. And then for every 500 feet, well, we've got this rate. So the decimal for 1.8 is 0.018. It is decreasing. Isn't this that one where we have to, you can't just say it's negative 0.018. This is that one where you have to subtract from 1, I believe. So let's see. 1 minus and that's 0.982. Okay. So I got that because it's kind of like when cars are depreciating, if they're losing 20% of their value every year, then we, instead of using 20 as our multiplier, we say if they're losing 20, it means they're keeping 80% of their value. Well, this thing's losing 1.8%, so they're keeping 98.2%. So we're going to use the 98.2% or 0.982. It's kind of weird though, because it's not per foot, it's for every 500 feet. So we're going to have to account for that also. But let's see if we can do something with, now at least we have some kind of rate. It's not being compounded over and over, so it's not like the last problem where we have that kind of weirdness going on. But let's get this going. So B, we've determined, is 0.982. And I want to just write it to the, to the T or to the X. But there's that 500 there. So it's every 500 feet, it's losing 1.8%. So I know this is going to sound crazy, but, or you could say, well, this means per 500 feet, right? So it's time per 500 feet. So hopefully that is satisfactory to explain it. And then this gives me a Well, I mean, I kind of like this as my formula, but really if I wanted to get it exactly in y equals a times b to the x, I could simplify it even more, because I can use laws of exponents, and I can say, well, x over 500, that's kind of the same as 1 over 500 times x, and so I can move that inside the parentheses. Like that. And I can let my calculator calculate that for me. Let's see if your book did. Your book actually did let the calculator calculate that. And when you do that, now you have a rounded number. And we have 0.9. So now it's perfectly in y equals a times b to the x form. The only problem being you had to round it, which I guess is not that big of a problem. And then if I wanted to have a table and a graph, I think it's going to be a decreasing function. I'll plug in a, well, I guess that's why they're making us kind of put it in this form, because it's this form makes it much easier to graph than this form, I suppose. So let's use 0 and 1, my two favorites. So if that's the 0 power, I'm just going to have 101, and that gives me my starting point. And I'll just say that that's 101. And then if I raise that to the first power, then I can just ask my calculator. 0.9996 raised to the first power would still be 0.9996 times 101. And that gives me about 100.95. So maybe I could have let x be 500, because it's not gonna, it only goes down by 1.8% every 500 feet, and I only let it go down every time you go up a foot, or every time you go up in elevation 500 feet, the pressure goes down by 1.8%. I didn't even go up a whole 500 feet, I just went up by 1 foot. So that's why it doesn't show it increasing very much. I should have used a bigger number. So point. Raised to the 500 times. And I got 99. So it's not going down very steeply, but you can just show that it's going down. Probably not the most realistic graph. Okay, we're at about 9 minutes, so I think I'll do the next one on a different video.